Find the limit. The limit as x goes to infinity of 2 to the x divided by 3 to the x. If we try to evaluate this directly, of course 2 to the x is an exponential function, and as x gets bigger, 2 to the x is going to get bigger. So that's going to be infinity. Same thing for 3 to the x. So we get our indeterminate form, infinity over infinity. Now we could try to do L'Hopital's rule. However, this doesn't work well for us. We do the limit as x goes to infinity. The derivative of the numerator is the natural log of 2 times 2 to the x. The derivative of the denominator is the natural log of 3 times 3 to the x, and we still have the same problem. 2 to the x is going to go off to infinity. 3 to the x is going to go off to infinity, and we still have an indeterminate form. We could do L'Hopital's rule many times, but unfortunately, because of the nature of exponential functions, those exponential functions are not going to disappear. So rather, we apply a little bit of algebra first. The power of the 2 is x, the power of the 3 is x. So we may combine those together and say that this is the same as 2 divided by 3 to the power of x. Now as x gets larger and larger and larger, 2/3 to that power is going to get smaller and smaller and smaller. So this limit is going to be equal to 0. Remember, 2/3 to the x is a decreasing function. It's a decreasing exponential function. Because 2/3 is less than 1, this function is going to get closer to 0 as x approaches infinity. So in the end, our limit ends up being 0.